Well done. All right, welcome to the Engineer Construction Lecture Hub. This is a live streaming. Okay, as you can see, this is a cantilever. All right, this is a cantilever extended to this point. All right, now you can see that this reinforcement is the one carrying, this particular reinforcement. Okay, this particular one. Okay, all right, they are the ones transferring the load to this point. As you can see, it's been extended to this side, this other one too here. Okay, this provision here is also what supports the cantilever on this axis. Okay, so you can see now that this particular reinforcement is resting. The bottom of this, as you can see, the bottom of this, which is this, is resting on this other one that is coming this way. Okay, so this is the carrier of this outer concealed beam. All right, so this particular one is hinged, is extended down to that point. Okay, it's extended down to that point to balance, to give a balance. And understand that our cantilever, the tensile reinforcement is usually at the top. All right, it is the top that carries the load, the tensile stresses. So that is why you see this resting on top of these particular reinforcements. Okay, these ones are the ones carrying the cantilever. All right, so it is being projected down this way, as you can see. Okay, so we also have this outer, we also have an outer concealed beam here. Okay, we also have an outer concealed beam, and it's being anchored. Okay, it's being anchored at the midpoint there. Okay, it's being anchored at the midpoint there to give a balance. All right, to give a balance to this cantilever slab here. So we are at site. Work is ongoing. So they've done the required returns. You can see the length. You can see the length of our return. Okay, because of the cantilever, to give that stability that is required. So this cantilever crosses this beam. All right, it crosses this beam, as you can see. It crosses this beam. So this beam will provide support. Now all of this will be tied to this side of the slab. Okay, and that will give the required support for our cantilever, to be sustained. All right, so you can see the spacings we have here for the matting is 150, 150. So you can also see the extension of the cantilever returns. These are the returns. You can see we have up to 1.8, 1.9, 2 meter thereabout. Okay, so you can see these are the extension, the returns. Still ongoing, as you can see. Rebar work is still ongoing. Yeah. So stay connected to the Engineer Construction Lecture Hub for valuable updates as regards to construction. Now, there is something I want to also bring to our notice. When you look at the span, here, let's say this particular panel here, when you look at the span, you see that this side of the slab is the LY. Okay, this is the LY. As you can see, this is the LY. All right, that's the LY. Okay, then we have our LX this way. Okay, so the bottom of your mat is expected to run across the LX direction. So as you can see, these are the bottom reinforcements. Okay, these are the bottom reinforcements. So they are running across the short span of the slab. All right, why the near bottom? This is now the near bottom. Now I want you to understand, you know, in our slab we normally look out for the bottom reinforcement. We look at the near bottom reinforcement. Okay, we look at the top and near top reinforcement arrangement, but in this case now, as we are progressing now, I will just have to disclose this. So these are the bottom reinforcement. As you can see, these are the bottom reinforcements. All right, and they are expected to run across the short span of the panel. All right, while the near bottom runs, as you can see, these are the ones, the near bottom reinforcements. So they run across the bottom bar. All right, so, and also we must ensure that we provide good development length. Okay, so this provides anchorage here, the required anchorage at this point. Okay, yeah. All right, so this is a general rebar arrangement. So as you can see, this is a bar, this is a beam. All right, this is a primary beam, as you can see. Okay, why is it a primary beam? Is that it is carrying this particular beam, this beam that runs this way. Okay, this beam that runs this way is a secondary beam rather. So it's resting on the primary beam, and if you trace this particular beam down this way, you see that it is being supported by another beam there. All right, it's being supported. Let's just get there. So you can see it's being supported here. All right, it's being supported at this point. So that makes it a primary beam, because that makes it a secondary beam because it's resting. If you look at it, the bottom of the secondary beam is resting on the bottom of the primary beam. So this is a primary beam. Okay, this beam, all right, this beam now that runs to that point, okay, that runs that way, that runs this way, okay, that runs this way down to that point, is a primary beam. All right, why this particular beam is a secondary beam? So you can see now the bottom of the secondary beam is resting on the bottom, on top of the bottom of the primary beam, while the top of the secondary beam is resting on the top of the primary beam. So this primary beam gives support to the secondary beam. So understand that when positioning your reinforcement, you must understand their positions and their functions. Now, if this now that is a secondary beam, it's expected that you don't place this below. You don't place this below because this is a secondary beam. All right, it is a primary beam that carries the secondary beam. So it is an error to have this secondary beam below being supported by the primary beam. So understand this. These are ways we can place our reinforcement rightly, and we must provide proper anchorage. Okay, we have to provide proper anchorage. So understand that this particular beam that runs this way, okay, this beam that runs this way to that point, to this point, okay, to this particular point is a secondary beam. All right. Now, this particular beam that spans from this point, okay, all the way to that point, okay, all the way to that point is a primary beam. Okay, so that is why it's providing support. So you can see the secondary beam resting on the primary beam. All right, so we should understand this placement of our reinforcement. All right, so you can see rebar work is ongoing. Okay, this section has been returned already. The returns have been done already. Okay, so we also have a cantilever at this point. As you can see, we also have a cantilever at this point. All right, so understand, you can also see the return up to this point. Okay, you can see the return from that point. Now from that point we have more than 2 meters return, okay, from that point. So that will provide the required support. Then we also have a concealed beam, to centralize the load. So the concealed beam is there to provide the required retention, okay, for that cantilever. All right, so it's been extended to this point. So the support for the cantilever is being extended to this point, as you can see. All right, as you can see. Now understand something. Now if you look at this particular panel, okay, if you look at this particular panel from this point to this point, okay, is the LX. That is the short span. Okay, that is the short span from this point to this point. Okay, is a short span. Why from this point down to that point is a long span. All right. So now understand that this particular reinforcement, okay, this particular reinforcement travels from that point. This particular reinforcement travels from that point because that side is a short span for that particular panel, slab panel. So the bottom there, okay, or rather the top there, okay, you can see the top. Let's go there. Now see the top here. The top reinforcement, these are the top, that is the near bottom. All right, these are the near bottom reinforcement. Okay, they are the near bottom for this particular panel here. Now this reinforcement is being extended. This particular reinforcement for the slab is being extended to that point. Okay, it's been extended to that point, and that point for that particular panel is the short span. All right, why on this panel it is the long span. So on this long span, for this panel is being provided as a near bottom. Okay, these are near bottom. They are resting on the bottom bar. Now this is the same bar now crosses to that panel and becomes a bottom reinforcement. Okay, if you look at it, these are the near bottom on this particular panel, but once it gets to this other short span, the same reinforcement automatically it runs below. You can see it. That's the reinforcement, because on this side is at the top, okay, while on this side is at the bottom. All right, because this is a short span, so it gives it that required stability that the slab needs. Okay, so you must understand that reinforcement arrangement. You must understand that reinforcement arrangement is very, very key, in the stability of our structures. All right, so I think at this point now, at the end of the day, these columns will be terminated. They will be terminated at this point and extended outward, okay, because this is a cantilever trying to extend the space that we have. Okay, so that is why the cantilever is being provided. All right, so it's important when you're having your cantilever, you must ensure that you give it that required retention. Okay, the running of your reinforcement must be done orderly. Okay, the runners, the length, okay, for the runners, the returns rather, should be sufficient enough, because that is what gives the slab, the cantilever, that strength to be able to sustain. Because as you know, when we are talking about the flexural members, we know that the flexural members that are supported at both ends, they are, once they are loaded, they usually have stresses that are felt at both the tensile zone and the compression zone. So we try as much as possible to to provide the required reinforcement and the spacing arrangement to be able to overcome those moments that will be generated. Okay, that is also applicable to that of our cantilever. You see that our cantilever, the entire system changes. In a supported flexural member, you discover that the bottom zone is usually in tension, while the upper zone is usually in compression. But in that of cantilever, you see that the cantilever top will now be in tension, while the bottom will be in compression. So that is why it's important the top of our cantilever must be, given that required reinforcement arrangement to be able to overcome those tensile stresses that is felt at that area. Okay, so that is why you can see there is a provision for a concealed beam that will help to give that return, that stability, and also you see that the outer concealed beams are also anchored inwards, okay, to give it that horizontal stability. Okay, so these are some of the things we have to look out for, in rebar works. Okay, it's very, very important, because it is this that guarantees the stability, of our reinforced concrete structure. So as you can see, the preparation for the return of the runners is ongoing. It's ongoing, as you can see.
tie, don't tie that one. Huh? That max. Put that to show you. Don't tie this one. This runners. Don't tie the max for that table. That's what I show you now. For that your table that side. It will go like this. It will go like this. From there it will go like this.
You can see this is the extension of that gives support to the outer part of the staircase, due to the span. All right, so you can see this is a 16 mm diameter bar. All right, so this is being anchored on this beam. This is being anchored on this beam. So you must give it a good, sufficient anchor length, to where it will be anchored, and it should be on a beam so that the beam will provide the required support. Okay, so you can see it already laid. So this is a voided space. Okay. So please understand that the return that is ongoing now for the runners is usually L/4 at the edge support. Okay, L/4 at the edge support. L/4 means the length of the span. Okay, divided by 4. That will give you the length that will be returned as a runner. Okay, but the ones close or at the mid span, okay, intermediate beam sections, they are L/3. Okay, they are L/3. Okay, they are L/3. So you have to divide by 3 to get the support, just like we have at this point. For example, the rebar work is still ongoing. It means that at this point now, you're taking L/3. You're taking L/3 this way. You're taking L/3 this way. That is for the top reinforcement distribution. Okay. Although you consider the span, okay, the span available, the available span, that will also in your design. Usually we design for, top reinforcement arrangements. Okay, we have the top, we have the near top. So those ones runs, along the beam tops. Okay, but understand that those ones that runs on the beam tops, you have to have to do L/3 on the right hand side, L/3 on the left hand side. So that will now give you the required length that will provide the top reinforcement that will resist hugging moments. Okay, why at the edges? Okay, at the edges, just as we have here, it will be L/4 rather. It will be L/4. All of these edges, okay, they are L/4. Okay, so you divide the span by 4. So whatever it gives you, that is the length you are going to return as you run. That is what you're going to return, okay, to take care of, to balance and provide resistance for hugging effect. Okay, so these are some of the things I want you to understand. Okay. Now, also, you see that this is a panel. So understand that in the detailed drawing, you see that these reinforcements are the bottom. Okay, all of these reinforcements are the bottom. Now, for you to get this number of bottom that spans from this point to this point, okay, to that extreme, it means that you have to, divide. You have to divide, okay, this length by the spacing. In this context, we have 150 mm. So that is what will now give you the number that will run through this from this point, okay, to that other point that we have there. Okay, likewise this point to that point. To get the distribution bar, you have to divide by 150, then you add +1. So that will give you the number that will run through from this point to that point. So it's also applicable to other panels, okay, that constitute this slab. Now understand that in our design too, we usually design our slabs in panels. So all of these panels we are designed separately. Okay, all of these panels, okay, all of these panels we are designed separately. Now during detailing, all you need do is to get the reinforcement of similar diameters. Okay, you get the reinforcement of similar diameters, then you position the reinforcement where that is supposed to be bottom. You position it, then transfer to where that has to be top due to their span difference. Okay, due to their orientation in terms of this slab arrangement. So you just lay it accordingly. Okay, so you can also see this is a cantilever. Okay, this space here we have is a cantilever for a balcony. Now from that point now, a concealed beam is being extended up to and being supported at this point. As you can see, it's being supported at this point to give that required, support for the cantilever, and it's done with 16 mm diameter bar. Okay, it's done with 16 mm diameter bar, and the rings are the spacing of 350 millimeters. Okay.